In the screencast, we will continue to look at changes in CO2 levels and changes in temperature since they have been measured more accurately in the past 150 years. So we'll look within those 150 years and see what has changed, and we will compare those changes to the historical changes that we have talked about before, which is information that was derived information, not direct data measurements, but derived information from things like ice core analysis. And we're doing that with an eye to seeing whether the changes that we are seeing with the current data are caused by human activity. And we will also look at the current data versus historical changes to see whether any of those historical changes can be ruled out. So first I want to point you to a website by nasa.gov. nasa.gov NASA is an organization that has been able to gather actual data on measurements of things such as CO2 and temperature from throughout the world and synthesize that information on the website, plot that information on graphs so we can take a better look at it. And they also have some background information. So I recommend that you take a look at that website for a deeper dive into this information that I'm going to present next. So we were able to start measuring actual temperatures throughout the world since 1880. And so that has happened. NASA gathered the data from thousands of measurements and plotted them on a graph shown here. So first of all, let me point out the graph runs from about 1880 to 2010, where these measurements were made. NASA took all of these measurements that were made and averaged them together. And the average of all of these years is what's shown at the zero change line. Okay? So if we average this point and 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 this point, this is the zero line. And above it, you have temperature increases of 0.2, 0.4, or 0.6 degrees from this average line, or decreases of 0.2 or 0.4 from this average line. Okay, so, and by the way, NASA does update this data monthly, so you can continue on to see what's going on up until the current time. So you can see that compared with the average temperature of this entire time period, prior to about 1940, there was either average or cooler temperatures. And certainly by 1950 and above, and it was kind of going up and down, but was kind of somewhere around this baseline average. But since 1970, there has been a steady increase in the temperature anomaly. So here is some information for you, some data. Since 1880, temperatures have increased 0.8 degrees centigrade. Let me get you some other data. The average surface temperature from 2009 until the current times have increased 2.1 degrees Fahrenheit. Let's see, most of the warming has occurred in the last 40 years. The 6 warmest years on record have taken place since 2014. The 6 warmest years on record occurred between 2014 and 2019. So basically, all of those warmest years, all of those past 6 years were the warmest on record. The warmest of all time was 2016. So to backtrack for just a minute, that 0.8 degrees centigrade increase between 1880 and 2009 would be the same as a 1.4 degrees Fahrenheit increase. And then from 2009 until 2019, there has now been a 2.1 degree Fahrenheit increase. So you can see that we're adding to the already noticeable increases, and those additions have occurred since 2009, with again the 6 warmest years on records taking place between 2014 and 2019. Also of note is the fact that solar radiation has actually slightly decreased, not increased. So we can't say that solar radiation is the unnatural cause of this increase. Now, again, looking at a little bit older data, but it's still relevant today and continues on the same trend. On this map, it's a heat map, basically. It's a map of the surface temperature data showing the differences relative to the average temperature from 1951 to 1980. So again, averaged all of that surface temperature data from 1951 to 1980, and then listed whether the current temperature change was an increase of 0.5 degree, 1 degree, 2 degrees, 4 degrees, or a decrease of any of these numbers. And the takeaway point here is that the changes that have occurred are not globally uniform. So the entire globe did not increase by, let's say, 2 degrees or 4 degrees. So take a look at the map and see where the greatest warming occurred. So it's occurring in the northernmost latitudes, the Arctic Circle. And the degree of change there is quite high, ranging from 2 degrees Celsius to pockets of 4 degrees Celsius. And that's critical a little bit because of what we've already talked about. But when you have this warming here and you have less ice and snow cover, you also have less reflection of solar energy into the atmosphere. And since there's less reflection from ice and snow surfaces, there's going to be a positive feedback loop occurring here, where the more ice and snow that melt or don't come to fruition, the more the Arctic Circle will warm. Okay? And then you see the middle latitudes where some areas, such as the United States, have noticed only a mild increase. And therefore, we may not feel the urgency of addressing this change. However, you can see that portions of Europe and Asia, well, Eurasia, including Russia, etc., has started to warm significantly. And also some areas of Africa, for example, have also begun to increase in temperature. So the fact that the changes are not uniform over the entire surface of the Earth is of concern to scientists for several reasons. One being the positive feedback loop up here, but also being the perhaps lack of urgency being felt in areas that are not experiencing great changes as yet. All right, now we're going to turn our attention to a different aspect. We have been looking at temperature changes, and now we're going to look at current data on carbon dioxide. Excuse me. We are going to look at, the information on carbon dioxide and how it is tied to temperature changes. Excuse me. So, what is the relationship between CO2 and temperature? So we have yet another graph here. This one is going back in time many, many hundreds of thousands of years ago. And like the graph that we looked at previously. And we'll look at the temperature change in degrees C compared to present day temperatures on this graph, on this axis. And we'll look at CO2 in parts per million on this axis. So as you can see from the data that was excuse me, extrapolated from things like ice cores, the CO2 parts per million had at times peaked and decreased, and the peaks and decreases seem to be fairly cyclical. Most importantly, the highest peak that was ever determined was 300 parts per million of CO2. And generally speaking, it really never reached much above 285 except for that one measurement. So that will be important when we look at CO2 levels today, which I believe I may have already told you that as of November 2020, we were already up to 415 parts per million. So somewhere up here on the graph. So certainly higher than any of these other peaks ever reached. Okay. So the comparison with historical extrapolated data indicates that the CO2 concentration today is higher than it's ever been in Earth's history. But we can actually look at more recent data where CO2 was actually measured and see how it changed from 1958 until today. So CO2 was first measured in 1958 by a scientist named Charles David Keeling. And so it's shown here on the graph with the 1958 data through the 2010 data. And as you can see on the graph, we were at, 390 something in about 2010. And as I mentioned, November 2020, we're up to 415. So the graph just continued to rise. Okay, so let's look at the monthly average and the overall trend. The overall trend is shown in blue. So look at this data for yourself. Is the CO2 concentration increasing between 1958 and 2010, much less if you continue the graph on to today? Well, yes, it obviously is, and it doesn't seem to be abating in any way. So would that be natural or would that be human caused? What is the amount of fossil fuels that we've been burning since the 1960s? Has that increased? Have we increased the use of methane for producing electricity or heating our homes? Actually, bad example. Let me back away from that. That was methane, not CO2, which I'll look at separately. But any type of burning of fossil fuels or release of CO2 gas from everything from the end of the Iraq War that we had talked about to just basically burning gasoline in our cars or coal to produce electricity. There's clearly been a straightforward line going up and continues to go up as we burn more fossil fuels. Now, let's take a look at the purple line, the monthly average, which you can see goes up and down. So there's a peak and a valley and a peak and a valley, one peak and one valley within each year. So think about what would cause that. Why would there be more CO2 and less CO2 every year? Well, the less CO2 is when we have our trees that are taking CO2 out of the atmosphere for photosynthesis. And that would be the lower peak. The higher peak of CO2 is when the leaves in areas like deciduous forests, such as we have, lose their leaves and there is less CO2 being absorbed by the plants. And that's significant enough to see the variation on the graph, but it does, of course, vary globally. So I'll end the screencast with this more recent data and do a quick comparison to historical concentrations. Again, you can see the highest amounts of CO2 were always certainly below the 320 level. That's a safe statement. And if you extrapolate up to where we are now in 2020, we're at 415. I don't know, maybe that'd be about here. So we're on a straight up